All right, so we're diving into this paper you sent over,
Oh.
image captioning based on scene graphs, a survey.
Yes.
And
Really fascinating stuff.
yeah, it's a pretty deep dive into this whole world of using scene graphs to make image captioning better, especially when we're dealing with those really complex images.
Yeah, it's really interesting.
So I know you're an expert in all this stuff,
I try.
machine learning and data science and math and all that good stuff. So
hmm
I'm really excited to kind of get into the nitty-gritty with you
Yeah, definitely.
of how scene graphs actually work
Yeah,
and
sounds good.
how they apply to this image captioning world.
Yeah.
So one of the things the paper starts off by talking about is that traditional image captioning methods, even the ones that use all the cool deep learning stuff like
hmm
the encoder decoder architectures and transformers and reinforcement learning and GANs and all these things,
Yeah.
they actually fall short when it comes to
Well,
actually understanding those complex relationships within an image.
exactly. Yeah.
It's not enough to just say, oh, there's a cat and there's a table.
Yeah, you have to figure out what's going on between the objects, and that's really the big challenge.
Exactly. And the paper really makes the case that these scene graphs, by actually mapping out the relationships,
Yeah.
provide this much richer
Mhm.
understanding of the scene. It's not just a list of objects anymore.
Right.
So can you talk a little bit about how this blueprint of relationships actually works?
Yeah, so it's kind of like if you think about it like a network, right?
Okay.
So you have the objects in the image, like the cat, the table, and those would be like nodes in
Just
our network.
got it.
And then you have these things called edges, which represent the relationships between them.
Okay.
So you could have an edge between the cat and the table that says on, or
Excellent.
under, or next to, or whatever it is.
So it's kind of like giving the AI the ability to
Mm,
understand not just the pieces, but like
exactly.
the story of the
You
scene and
hit
it all.
it.
Yeah.
Gives it context.
Yeah. Yeah, that's fascinating.
Yeah.
Now, the paper gets into a lot of different ways that people have tried to generate these scene graphs.
Right.
And it seems like there's been quite an evolution of approaches, right?
Yeah, there's been a lot of progress in the last few years.
Yeah. So can you walk us through kind of like the history of that a little bit?
Yeah, so initially people were using CNNs a lot.
Okay.
They were basically extracting features from the images
Right.
and trying to use those to predict the relationships between objects.
Yeah.
But they ran into some problems, like they're computationally very expensive,
Uh-huh.
and they also had trouble with really nuanced relationships.
I've got it.
And then people started using RNNs and LSTMs,
Okay.
which are better at handling sequences of data.
Right.
So they were able to capture more context,
Yeah.
but they were also kind of slow.
Mm.
And then more recently, people have started using graph neural networks and
Oh.
transformers, which are proving to be really powerful.
So it seems like those are kind of the current front runners in this area.
Yeah, definitely.
Now the paper seems to really emphasize
Yeah.
GNNs as being particularly well suited for this scene graph generation
Yeah.
because of their
Yeah.
ability to work with these graph structures.
Right, exactly.
So can you talk a little bit about some of the
Yeah.
standout approaches there that are mentioned in the paper?
Yeah. So one example is graph RCNN.
Okay.
So basically what that does is it takes an initial scene graph
Okay.
and it uses a GNN to refine it.
Got it.
So it can prune away unlikely connections
Uh-huh.
and emphasize more relevant ones.
That makes sense.
Yeah.
Now, as far as the transformers go,
Yeah.
we've heard a lot about those in other areas of AI and
Yeah.
deep learning.
Right.
But they're also making their way into this scene graph generation world.
Exactly.
So can you talk about some of the
Yeah.
key examples there?
Yeah. So one example is RelTR, and that's a transformer-based model that directly predicts relationships between objects.
Okay.
So it doesn't have to go through this intermediate step of extracting features.
Got it.
So it's more efficient.
Uh-huh.
And then another example is the spatial temporal transformer.
Okay.
And that's really good for handling dynamic scenes.
So like video analysis and things like that.
Exactly, yeah.
Interesting.
Yeah, it can capture the evolution of relationships over time.
Yeah, that makes sense.
Yeah.
Now, one of the things that the paper emphasizes is that when we're generating these scene graphs, it's not always enough to just rely on the image itself.
Right.
Sometimes we need to bring in some prior knowledge.
Yeah, especially if you don't have a lot of training data,
Okay.
it can be really helpful to incorporate prior knowledge.
So what kinds of prior knowledge are we talking about here?
So it could be things like human-defined rules.
Okay.
Like, for example, that a cat is usually smaller than a table. Or it could be statistical patterns that you've learned from a large data set.
Got it.
Or it could even be knowledge graphs,
Okay.
which are basically databases of facts about the world.
Yeah.
So all of these things can help to improve the quality of the scene graphs.
So it's kind of like giving the system a little bit of common sense.
Exactly.
Yeah, that's interesting.
Yeah.
Now let's talk about how these scene graphs are actually used in image captioning.
Okay.
The paper
Yeah.
makes a pretty compelling case for how they bridge this gap between vision and language.
Right.
So can you walk us through kind of that process of how that works?
Yeah. So basically, once you have the scene graph,
Mm-hmm.
you extract features from both the objects and the relationships.
Okay,
And then you encode those features.
got it.
And then you feed those into an LSTM or some other kind of language model.
Okay.
And that generates the caption.
So the scene graph is really kind of like the foundation for the whole thing.
Exactly.
And the paper outlines several advantages of using these scene graphs
Yeah.
in image captioning.
Right.
And again, it's not just about identifying the objects. It's about
Yeah. It's about understanding the story they tell.
understanding the story. Yeah.
Yeah.
So can you elaborate a little bit on those advantages?
Yeah. So first of all, scene graphs allow you to capture the spatial and semantic relationships between objects.
Got it.
So that leads to more accurate descriptions, especially for complex images.
Yep.
And it also leads to more detailed descriptions.
Okay.
And importantly, it leads to more human-like descriptions.
So it's really trying to mimic the way that we as humans understand these scenes.
Yeah, we don't just see a list of objects, we
Right.
see a story.
Yeah, absolutely.
And then another advantage is that scene graphs can help you to achieve diversity, anchoring, and controllability in caption generation.
So what does that mean exactly?
So basically, by manipulating the scene graph,
Okay,
you can guide the focus of the caption.
got it.
So you can highlight specific aspects of the image,
Uh-huh.
or you can generate descriptions with varying levels of detail,
I see.
or you can even generate descriptions from different perspectives.
So it gives you a lot more control over
Exactly.
the output.
Yeah.
Now, the paper also delves into a bunch of different specific approaches to
Right.
using scene graphs for image captioning.
Mm-hmm.
And it would be great to kind of get into a
Yeah.
couple of those examples.
Okay.
So what are some of the ones that really stand out to you?
So one example is MSDN,
Okay.
and that basically combines scene graph generation with object detection
Uh-huh.
and region captioning.
Got it.
So it can generate detailed descriptions of different segments of the image,
Okay.
and then it weaves those together into a coherent whole.
That's cool.
Yeah. What else?
Another interesting approach is SGAE.
Okay.
And that uses scene graphs to embed common sense knowledge into the captioning model. So it's kind of like going back to that idea of giving it some prior information.
Yeah.
And how does that work in practice?
So basically, it uses the scene graph to constrain the space of possible captions.
Okay.
So it makes sure that the captions are consistent with the relationships
Oh,
that are depicted in the scene graph.
that makes sense.
Yeah.
Any other interesting examples?
Yeah. Another one is ASG.
Okay.
And that stands for Abstract Scene Graph.
All right.
And basically, it allows users to specify the desired focus of the caption.
I see.
So, for example, you could say, I want a caption that focuses on the cat,
Yeah.
or I want a caption that focuses on the interaction between the cat and the table.
Got it.
And then the system will generate a caption that meets those requirements.
So that's pretty cool. It gives the
I know,
user
it gives you a lot of control.
a lot of control. Now,
Yeah.
of course, the paper also dedicates a good chunk of time to discussing data sets and evaluation metrics,
Right.
which are obviously essential for any machine learning task.
Mm-hmm.
So can you talk a little bit about some of the key data sets that are used in this field?
Yeah, so some of the most popular data sets are MS-COSIO,
Okay.
Visual Genome,
Mhm.
and VG-COSIO.
Got it.
And those all contain large collections of images,
Yeah.
captions, and scene graphs.
So they provide kind of the training data
Exactly.
for these models.
Yeah.
Now, as far as the evaluation metrics go,
Yeah.
we have things like BLEU and Rouge,
Mhm.
which are kind of the standard metrics for
With
evaluating
statistical overlap.
text generation.
Mm-hmm.
But
But they're not always the best for evaluating image captioning.
are there other metrics that are more appropriate?
Yeah, there are a lot of other metrics
know
that
what I'm
people have proposed.
Yeah.
So, for example, there's CIDR,
Okay.
which assesses the grammaticality and
Oh.
salience of the caption.
Got it.
And then there's spice, which focuses on capturing the entities and relationships from the scene graph.
I see.
And then there's spider,
All right.
which combines cider and spice.
So it's a more holistic
Yeah,
kind of evaluation.
exactly.
Now let's get to the nitty-gritty here of comparing these scene graph-based methods
Yeah.
with these traditional deep learning approaches. The paper seems to be suggesting that the scene graphs are really starting to pull ahead,
Right.
especially when we're talking about these complex images.
Yeah, that's definitely the trend.
So why is that? Why are these scene graph methods doing so well?
Well, basically, because they have this structured representation, they're able to understand the relationships between objects in a way that deep learning models can't.
Got it.
So they're able to generate more accurate descriptions,
Okay.
especially for complex scenes.
That makes sense.
Yeah.
Now, the paper actually provides a really interesting comparison
Yeah.
in Table 5, and we'll definitely dive into that in more detail in the next part of our deep dive.
It's good. Yeah.
But for now, I think we've laid a really good foundation
Yeah, I think so.
for understanding this whole world
not the
of
cafe.
scene graph-based image captioning.
Yeah. It's a really exciting field.
It is. It is. And we'll come back in the next part
Sounds good.
and really get into the weeds of some of those comparisons
Okay, great.
and some of the future directions for this research.
Looking forward to it.
All right. Thanks.
Yeah, thanks.
We'll be right back.
So picking up where we left off, let's dive into Table 5 from the paper,
Okay.
which really gives us this nice comparison of how these scene graph-based methods
Right.
stack up against those deep learning approaches.
Yeah. It really highlights the strengths and weaknesses of each approach.
Exactly. And
Yeah.
one example that really stood out to me was the SGAE model. Remember that one that leverages scene graphs to kind of inject that common sense knowledge?
Right. Right.
And it actually outperforms deep learning models
Yeah.
in metrics like BLEU and CIDR, especially when we're describing those complex images.
So that's a pretty clear demonstration of how that structural understanding
Yeah.
from the scene graph really enhances the accuracy
Exactly.
of the captions.
You're giving it that extra information.
Yeah.
It needs to make sense of the scene.
Yeah, yeah. Now,
Is there ever a time when the deep learning methods
oh yeah.
might actually be a better choice?
Yeah, so if you have an image that's pretty simple,
Okay.
maybe it just has a couple of objects and the relationships are really clear, then a deep learning model might actually be more efficient.
Got it.
It might not need all the extra complexity of a scene graph.
So it's kind of like there's no one-size-fits-all solution here.
Exactly.
It really depends on
It depends on the image.
the image.
Yeah.
Now, the paper suggests that,
Maybe what we need is a more dynamic approach
right, that'd be ideal.
where the system can actually analyze the image
Yeah.
and decide which method
Yeah.
is going to be best.
Figure out how complex the scene is.
Yeah.
And then choose the right tool for the job.
That's really interesting.
Yeah, it's a challenging problem, but I think it's definitely worth exploring.
Now, moving beyond this comparison,
Yeah.
the paper also gets into some really fascinating future research directions. And I know you have a deep understanding of this field, so
I try to keep up with it.
I'd love to hear your thoughts on which ones really stand out as particularly promising.
Okay, so one area that I think is really important is addressing this challenge of out-of-domain data.
Right, because right now, a lot of these models,
Exactly.
they struggle when they encounter images
Yeah.
that are different from what they were trained on.
If they haven't seen it before,
Yeah.
they don't know what to do.
It's like expecting someone to understand a foreign language after just learning a few basic phrases.
Yeah, that's a good analogy.
Now, the paper suggests that scene graphs might actually be helpful here
Right, because
they capture these relationships between objects,
yeah, the relationships are more generalizable.
which are more generalizable than the objects themselves.
Yeah, exactly.
So it's kind of like the scene graph is acting as a universal translator for the visual world.
Yeah, in a way.
Now, the paper also talks about the need for more sophisticated evaluation metrics
Oh, yeah, that's a big one.
because, as we discussed,
Yeah.
BLEU and Rouge,
Yeah.
they're useful, but
They don't tell the whole story.
they don't really capture the essence of a good caption.
Exactly, yeah.
So what are some of the ideas out there
Well, people are looking at
for better evaluation metrics?
reinforcement learning and adversarial training
All right.
as ways to develop metrics that align better with human judgment.
So we really need to think about how humans evaluate these captions and try to capture that on a metric. That makes sense.
It's a tough problem,
Yeah.
but it's an important one.
Now, shifting gears a little bit,
Okay.
the paper also mentions the idea of incorporating super resolution techniques
Yeah, that's interesting.
into this scene graph-based image captioning.
Yeah.
So essentially enhancing the resolution of the image
Exactly.
before processing.
Yeah, because sometimes the images are just too blurry.
Yeah, especially in real-world applications
Right.
where the image quality might not be so great.
Yeah, you need to be able to handle that.
So clearer images lead to clearer understanding.
Yeah, basically.
The paper also talks about this issue of object hallucination,
Oh, yeah, that's a funny one.
where the model generates captions
Right.
for objects that aren't actually there.
Yeah, it's like the model's getting a little too creative.
So how do we deal with that problem?
Well, the paper suggests that scene graphs might actually be helpful here
Okay.
because they provide this framework of plausible relationships. So it's less likely that the model will hallucinate objects
That makes sense.
that don't fit within that framework.
So it's kind of like the scene graph is acting as a reality check
Yeah,
for
exactly.
the model's imagination.
Yeah, that's a good way to put it.
Now, the paper also emphasizes the importance of incorporating
Yeah.
external knowledge and common sense reasoning
Right, because you want the model to be able to
into these systems.
understand the world beyond just the image.
Yeah, to really understand the context of the image.
Yeah.
So how do we go about doing that?
Well, one way is to use knowledge graphs,
Okay.
which are basically databases of facts about the world.
Yeah.
And another way is to use common sense databases,
Got it.
which are basically collections of rules of thumb.
Right.
And all of this can help to make the captions more intelligent and insightful.
So it's kind of like giving the model
Yeah.
a broader education about the world.
Exactly.
Yeah, that's really interesting.
Yeah.
No.
Yeah. Speaking of pushing the boundaries,
Yeah.
the paper also talks about this idea of multimodality.
So going beyond just
Yeah.
visual input,
Bringing in other senses,
Yeah.
like audio or text or even touch.
so we could have captions that describe not only what we see,
Exactly.
but also what we hear
Yeah. Or even what we feel.
and what we feel.
Yeah.
That's amazing.
Yeah, it'd be really cool.
And how would scene graphs play into that?
Well, they could represent the relationships
Okay.
between entities from different modalities.
Got it.
So, for example, you could have a scene graph that connects a visual object
Yeah.
to an audio clip
Okay.
or to a piece of text.
So it's really this hub for integrating all
Yeah.
these different
Yeah.
sources of information.
Yeah,
Now, the paper also talks about interactive image captioning,
right.
where the user can actually provide feedback
Yeah.
or ask questions
Yeah, that's a really interesting idea.
during the caption generation process.
Yeah, because it makes it more of a collaboration between the
Exactly.
user and the system.
And how would scene graphs
Right.
be useful in that context?
They're easy to manipulate,
Okay.
so the user could actually interact
Got it.
with the scene graph directly.
That makes sense.
Yeah.
Now, moving beyond just image captioning,
Okay.
the paper also highlights some broader applications of scene graphs in
Yeah.
other areas.
Yeah, like image retrieval, for example.
Okay.
You could use a scene graph
Mhm.
to search for images
Right.
based on relationships between objects.
So I could search for a cat sitting on a table
Exactly.
and actually get images of
And you would get exactly
a
that.
cat sitting on a table.
Not just a bunch of random cats and tables.
That's amazing.
Yeah, it would be much more precise.
What about robotics?
Oh, yeah. Robotics is another big one.
How would scene graphs be used there?
Well, they could give robots a better understanding
Okay.
of their environment. So they could navigate more effectively
Uh-huh.
and they could interact with objects more intelligently.
That makes sense.
Yeah.
The paper even mentions medical diagnosis.
Oh, wow.
So how would scene graphs be applied there?
Well, you could use them
Okay.
to analyze medical images,
Yeah.
like X-rays or CT scans.
Right.
And they could help doctors to identify patterns.
So they could assist with
Yeah.
the diagnosis process.
Yeah.
That's really fascinating.
Yeah, it's pretty amazing.
So this technology has implications far beyond just generating image descriptions.
Oh, yeah, definitely.
It really has the potential to revolutionize
It could change the world.
many different fields.
Yeah, I think so.
Now, as we wrap up this part of our deep dives,
Okay.
the paper concludes by emphasizing the significance of this whole field of scene graph-based image captioning
Right.
and its role in advancing our understanding of images.
Yeah, it's a really important area of research.
It really is. But it also acknowledges that this is still a relatively young field,
Oh, yeah, there's still a lot we don't know.
and there are many open questions and challenges
Right, there's always more to learn.
that still need to be addressed.
Exactly.
So let's move on to the final part of our deep dive
Sounds good.
and explore those future directions in
Oh.
more detail.
Looking forward to it.
All right, so as we get into this final part of our deep dive,
Okay.
the paper outlines several kind of promising research avenues
Right.
that could really shape the future
Yeah,
of this whole scene graph-based image captioning.
definitely.
And one area that really jumps out,
Mm-hmm.
especially given all the challenges we've talked about with limited data,
Right.
is this exploration of unsupervised
Yeah.
or weakly supervised approaches for generating these scene graphs.
That would be huge.
Yeah, because if we can reduce that reliance on these massive,
Exactly.
meticulously labeled data sets,
It would make it so much easier
it would make this technology
to apply this to different problems.
so much more accessible
Yeah.
and applicable to all sorts of different scenarios.
Perfect.
Now, another thing the paper talks about is this need for models
Yeah.
that can handle out-of-domain data.
Right. Yeah, that's a big one.
Because right now,
Because if you show these models something
yeah, a lot of these models,
they've never seen before,
they just fall apart
they freak out.
when they see images
Yeah,
that are different from what they were trained on.
exactly.
So how do we get to that point
Well, I think the key is
where they can achieve that true robustness
to incorporate more external knowledge.
and generalizability?
Yeah.
And the paper suggests that
And common sense reasoning.
maybe incorporating external knowledge sources and common sense reasoning could be a big part of that.
Exactly.
It's like giving these models
You got to teach them about the world.
a broader understanding of the world
Yeah.
beyond just those specific objects and scenes
Not just the stuff they've seen in the training data.
that they've been trained on.
Right.
Now, another exciting direction
Yeah.
that the paper points to is this idea of multimodality.
Mm-hmm.
So going beyond just that visual input
Yeah. Bringing in other senses.
and incorporating
like audio or text.
audio, text, even tactile information.
Yeah. Even touch.
Imagine a system,
That would be amazing.
and it could describe not only what it sees in an image,
Yeah.
but also what it hears
Or what it feels.
or feels.
Yeah.
That's really kind of mind-blowing.
It's pretty wild.
And the paper argues that
Yeah.
scene graphs could actually play a key role in this multimodal future
Right. Because they can represent
by representing those relationships between entities
relationships between different modalities.
from all these different modalities.
Yeah, exactly.
Now, finally, the paper
Mm-hmm.
really stresses this need for more sophisticated evaluation metrics.
Yeah, we've got to do better than just BLEU and Rouge.
Yeah, because as we discussed,
Yeah.
BLEU and Rouge, they're okay.
They're a good starting point.
They give us some basic information,
Yeah.
but they don't always capture
They don't capture the nuances.
the nuances of a truly good caption.
Yeah.
So we need to think about things like
Like factuality,
factuality, coherence,
coherence, relevance, all that good stuff.
all these things that humans really consider
Yeah.
when they're evaluating the quality of a caption.
Humans are still the gold standard.
So we need to develop metrics
Right?
that really align with human judgment.
Yeah, that's the goal.
So as we wrap up this deep dive,
Okay.
it's clear that this whole world
It's a fascinating field.
of scene graph-based image captioning
Yeah, it really
is just bursting with possibilities,
Definitely.
both in terms
It's
of
moving so fast.
the technology itself
Yeah.
and the potential impact it could have
It has the potential to change everything.
across so many different domains.
I think so.
And the paper really does a great job
Yeah, it's a great overview.
of not only summarizing the progress
Mhm.
that's been made so far,
Right.
but also highlighting
And it points to some really exciting directions.
all these exciting challenges
Yeah.
and opportunities that are still out there.
Definitely.
So to summarize
Okay.
for our listeners,
Mm-hmm.
the key takeaway here is that
Scene graphs are the future.
scene graphs,
Yeah.
with their ability to really capture
They can understand images
those rich relationships within an image,
in a way that we've never been able to before.
are proving to be a real game changer
Yeah.
in this whole world of image captioning.
You're making a big difference already.
They're allowing for more accurate,
And they're only going to get better.
more detailed,
Yeah.
more human-like descriptions.
Yeah, exactly.
Especially when we're dealing with
Especially for those complex
and
scenes
complex scenes
where traditional methods just fall apart.
where the traditional methods really struggle
Yeah.
and the field is constantly evolving.
Oh, yeah, it's moving so fast.
Researchers are exploring all sorts of
Architectures?
novel architectures,
New ways to incorporate prior knowledge.
incorporating prior knowledge,
Trying to make these models more robust.
striving for greater robustness and generalizability,
Yeah.
and really thinking about
And we need better valuation metrics.
how to develop those more
Yeah.
sophisticated evaluation metrics.
Yeah, that's crucial.
So ultimately,
Mm.
this technology has the potential
I think it could revolutionize
to really revolutionize how we interact with images,
How we understand images.
opening up possibilities
Yeah.
in fields ranging from assistive technologies
Like helping people with visual impairments.
to content creation to
Creating new forms of art.
medical diagnosis.
Yeah, the possibilities are endless.
And as research
Who
continues,
knows what we'll discover.
I think we can expect even more remarkable breakthroughs
I can't wait to see what the future holds.
in this field.
Me too.
So thank you so much for guiding us through this
Oh, it's been my pleasure.
fascinating deep dive.
Yeah, it's been a great conversation.
Your expertise has been invaluable.
I'm glad I could help.
And to our listeners,
Keep exploring.
we hope you enjoyed this exploration
Yeah, don't be afraid to get your hands dirty.
into the exciting world of
And play around with some of these models.
scene graph-based image captioning.
Yeah, have fun with it.
Thanks for listening.